This video is intended to help you through the computer project that is part of Unit 7 on the variability of the number of heads when a coin is flipped a given number of times. As usual, I will use numbers different from those specified in the unit assignment, so you shouldn't expect your answers to come out the same as mine. I suggest that you answer the preliminary questions on the first sheet of the spreadsheet. I'm using Google Docs again, so to keep the rows from expanding, I suggest that you click on the letter of the column where the answers will go, and then click and hold on to the dividing line between that column and the next. The cursor should be a left-right arrow. You can move that dividing line to widen the column as you wish. Then you can type in your answers. But then you'll need a new sheet in the spreadsheet where you'll put the actual simulations. So go to the bottom of the spreadsheet and click on the Add button to get one. In Excel, I wouldn't need to add any sheets. When you open an Excel spreadsheet, it has 3 pages by default, and you can switch between them just by clicking on their tabs at the bottom of the page. Next, the instructions say to repeat 30 times each of the following simulated experiments. Flip a coin 10 and 40 and 160 times, and count the number of heads. Changing numbers, as I mentioned above, I'll repeat 25 times, flipping a coin 10, 50, and 250 times. Moreover, I'll simulate an unfair coin, one that comes up heads 60% of the time. You're supposed to use a fair coin, 50% heads. I'll put some labels in column A, the counts of heads in the first 3 rows of the next 25 columns, and the results in the first few rows of the columns after that. So I'll need at least 253 rows and 30 columns. In Excel, I wouldn't have to add rows or columns. If you move the cursor to them, they will just be there. But with Google Docs, to get more rows, I go to the bottom of the sheet and instruct the spreadsheet program to add 153 rows to the default 100. To get more columns, I highlight columns B through T, the last of the default columns, and insert 19 more columns to the right. That's more than I need, of course, but it's either that or add them one at a time. Because the columns where the coin flips will appear and be counted will only have a few digits in each cell, they can be narrow. So I highlight those 25 columns, B through Z, and adjust the width of column B. They will all be given that same width. I can also adjust the widths of the other columns to fit their contents. After I've put in a few labels, it's time to simulate flipping a coin, as I said, an unfair one. The function equals rand, open paren, close paren, gives a number somewhere in the interval from 0 to 1, anywhere in the interval with equal probability. So about 60% of the time it will come up less than 6/10. I'll indicate a head in the spreadsheet with a 1 and a tail with a 0. That way the count of heads is just the sum of the cells. So in cell B4 I type equals if, open paren, RAND, open paren, close paren, is less than 0.6, comma, 1, comma, 0, close paren. In other words, if the random number comes up less than 6/10, put a 1 in the cell. Otherwise, put a 0 in it. I can drag that formula all the way down to B253 and then across to Z253. So I get 250 times 25, or 6,250 flips of this unfair coin. At the head of each column, the first of each 250 flips can be the 10 flips that we're supposed to do, and the first 50 of the 250 can be the specified 50. We weren't instructed to make them separate trials, so we put the counts of heads, that is, the sums of the desired cells, at the top of each of the columns, B through Z. For example, in B2, we could put equals sum, open paren, B4, colon, B53, close paren. The spreadsheet program will be slow to react. Every time you change an entry from this point on, it will recompute everything in the sheet, including all 6,250 random numbers. So give it a moment. It'll get there eventually. Anyway, once we have the 3 formulas in column B, we can drag them across to column Z. Then starting in column AA, we can put the averages and SDs of the values B1 through Z1 B2 through Z2, and B3 through Z3. Remember, we're still using STDEVP for standard deviation. Also, we're supposed to count how many times the simulation gives exactly half heads. Half of 10 is 5, so we want to know how many of B1 through Z1 are exactly 5. The formula is equals count if, open paren B1 colon Z1, comma, quotation marks, equals 5, quotation marks, close paren. The quotation marks are necessary. Now, because we're supposed to find roughly how much bigger the averages and SDs are for 50 than for 10, and for 250 than for 50, I suggest that you find those ratios, rounded off to 0 decimal places for the average and the SD, or maybe 1 decimal place for the SD, because the SD is usually an ugly decimal. The formula for 1 decimal place in cell AC6 is equals round, open paren AB6 slash AB5, comma, 1, close paren. Some of your results may seem wrong to you, and indeed they may occasionally by chance violate a general rule. You can easily test this out by rerunning the whole simulation. Because the spreadsheet recalculates everything when any entry is changed, you can pick any cell that you haven't used and type something into it, and the spreadsheet will redo the whole simulation. Changing that meaningless entry a few times, you can see whether the wrong result was a misleading accident or correct in most cases. Finally, you can answer the last questions on this sheet, or you can add a third sheet and answer them there.